Rahim. Assalamu alaikum students. I am Ms. Atya, your chemistry teacher. Welcome to APSEC's online support program. Today students we will discuss actual yield and theoretical yield. Yield means the amount of product that is obtained in a chemical reaction. There are two types of yield, theoretical yield and actual yield. Theoretical yield means the quantity of product which is calculated from a balanced chemical equation, means the amount of product that we calculate from a balanced chemical equation during stoichiometric calculations. The amount of product that is obtained during stoichiometric calculations is known as theoretical yield. The second yield is actual yield. Actual yield means the quantity of product that is actually produced in a chemical reaction. That is the amount of product that we obtain during the experimentation process. So that yield is known as actual yield. And percentage yield means efficiency of a chemical reaction, means how much efficient is a chemical reaction. Chemical reaction can be 100% efficient, or it can be 95% efficient, or it can be 50% efficient. So we calculate the efficiency of a chemical reaction by calculating the percentage yield. In order to calculate percentage yield, the actual yield is taken in the numerator and the theoretical yield in the denominator, and it's multiplied by 100. In some chemical processes, the actual yield is almost equal to the theoretical yield. Means the reactions are 100% efficient. Means the reaction, the percentage yield of the reaction is 100%. And this happens during chemical analysis. Chemical analysis, you will do chemical analysis in your second year class. In chemical analysis, you will be given a salt and you will be asked to analyze that salt. Means you will be asked to tell whether which salt is given to you. You will perform some tests. So that process is known as chemical analysis. But in some reactions involving organic compounds, the actual yield is less than the theoretical yield. Means the percentage yield is not 100%, because the actual yield is less than the theoretical yield. So the actual yield may be less than the theoretical yield due to some reasons. The first reason is the side reactions may take place. In side reactions, what happens, for example, a reactant A is converted into product B. This is the main product that we want, and this is the main reaction. But sometimes what happens, some side reactions may take place and the reactant A may be converted into product C. This is the byproduct that we don't want. So due to the formation of product C, we don't get the actual yield of product B. Means the amount of product B is reduced due to the formation of product C, because some of the reactant A is converted into the product C. So this is the main reaction and this is the side reaction. So due to side reaction, some byproducts may be formed, and due to the formation of byproducts, the actual yield of the main product is reduced. The second reason, students, may be that some reversible reactions may take place. In reversible reactions, the reactants are converted into products, and after some time the products are converted back into the reactants. So due to these reversible reactions, we may not get the actual amount of product. So in that case also, the actual yield is less than the theoretical yield. The third reason may be the mechanical loss may take place. Means during handling of apparatus, some loss of product may take place, and the processes can be filtration, distillation, separation by separating funnel, washing, and crystallization. This is a crystallization process. In this process, first of all, for example, we have an impure solid and we want a pure solid, for example we have impure copper sulfate and we want to get pure copper sulfate crystals, so what we will do, we will prepare a saturated solution of copper sulfate, then we will filter the solution. This is the filtration process. During the filtration process, some contents of the solution may remain in the beaker, thus decreasing the actual yield. Then we will get that filtered solution in an evaporating dish. We will evaporate that solution and we will cool the solution, and then after cooling, after some times, we will get pure crystals of copper sulfate. Then we will separate the copper sulfate crystals from this liquid. During that process also, when we will filter the solution to get pure copper sulfate crystals, then also some contents may remain, some crystals may remain in the beaker, so the actual yield of copper sulfate may be reduced. We will also wash these copper sulfate crystals so that to remove any impurity that may be present. During washing process also, some copper sulfate crystals may be lost. So mechanical loss can take place during filtration process, during washing of crystals, etc. This is also a separation technique. In this separation technique, we use a separating funnel. In this separating funnel, we take two immiscible liquids such as water and oil. Immiscible liquids are liquids that do not dissolve in each other. For example, we take a mixture of water and oil in a separating funnel. Then we will keep this mixture undisturbed for some time. We will see that two layers are obtained. The bottom layer is that of water because water is denser, and the top layer is that of oil because oil is lighter than water. Then we will open this tap. The water will move into this beaker dropwise, and we will continue the process until all of the water is separated, and then we will close the tap. In this way, the water is and the oil is separated from each other, but it's not necessary that 100% water is separated from oil. The yield of water may be less, so in this process also the actual yield may be less than theoretical yield. This is a distillation process. In distillation process, for example, we have a mixture of liquid and a non-volatile solid. Non-volatile solid is a solid that does not evaporate. We want to separate this liquid from this non-volatile solid. So what we will do, we will take this mixture in a distillation flask. This distillation flask is connected to a condenser. This condenser, in this condenser, the cold water is circulating in and out, and we have a receiving flask over here. We will heat the liquid. At the boiling point, the liquid will change into vapors, and these vapors will move into this condenser. Then when they will touch the cold surface of the condenser, these vapors are condensed back into the liquid, and this liquid is collected in the receiving flask. So it's not necessary that we get 100% liquid in this receiving flask. Some liquid may remain in this condenser, so the actual yield is less than the theoretical yield in this process also. This short question, students, this short question is very important. It usually comes in the paper. Why? The question is that they will ask the question that why the actual yield is less than the theoretical yield. Give 3 reasons. So you have to give these 3 reasons. Thank you very much, students.